Hello friends, welcome to online lecture series. Today we will just start the new topic, Newton's law of cooling, second application of differential equation. So let's start. Newton's law of cooling. We know that the temperature of the body is transformed from high temperature to low temperature. One simple example of the Newton's cooling law is shown in a figure. The cup that contains hot liquid. The temperature of the liquid is greater than the temperature of the surrounding. Due to that, the temperature of your liquid is reduced as your time goes on increasing. So the simple graph of such a cooling of this hot water with respect to time is shown in this particular figure. The temperature of your that hot water is reduced as your time goes on increasing. So the temperature of your hot water is depends on the time as well as the temperature of your surrounding. So this concept is introduced by the Newton's, and he stated that it is nothing but the Newton's cooling law. The statement of your Newton's cooling law is the rate of change of your temperature of the body is proportional to the difference of the body and the temperature of the surrounding medium. Means when we kept any particular hot body in surrounding, the surrounding temperature, due to that, the heated body change its temperature as your time is elapsed. So this particular statement can be defined in the form of the differentiable equation. Suppose the temperature of the body at any time t is suppose theta, and the temperature of the surrounding in which we are keeping the particles or the body, which is theta naught. Then the rate of change of your temperature with respect to time is directly proportional to the difference between the temperature of your body and the temperature which is kept at the surrounding can be defined in the mathematical form d theta upon dt is directly proportional to theta minus theta naught. When this directly proportional is converted into equation, and that equation is d theta upon dt minus k theta minus theta naught, where k is the constant of proportionality and the minus sign is attached due to the temperature of the body is increases at the time your time is decreases, or in the reverse, if the time increases, the temperature of your body goes on decreasing. Due to that, the negative sign is attached to this differentiable equation. So we said that when the negative sign is removed from this differentiable equation, it is said to be the heating law, or the process of heating is occur in that condition. And the body of the cooling at the rate k theta and the heated at the rate at the net rate change is d theta upon dt is minus k theta plus some alpha times t. This is the scenario. We will see some example of your Newton's cooling. A body originally at 80 degrees Celsius means the initial temperature of the body is 80 degrees Celsius, cools to 60 degrees Celsius in 20 minutes. The temperature of the air being 40 degrees Celsius, what will be the temperature of the body after 40 minutes? Means they ask, what is the body temperature after the 40 minutes? Initially, the temperature of your body is 80 degrees Celsius and it's cooled to 60 degrees Celsius in 20 minutes. So we have to just assume the temperature of your body initially at any time t is supposed theta. So according to the condition in this particular example, at initially the temperature is 80 degrees Celsius, means at t is equal to 0, the temperature of your body is equal to 80 degrees Celsius. In 20 minutes, the body changed its temperature from 80 to 60. As the time elapsed, the temperature goes on decreasing. And they ask, what is the temperature of your body after the 40 minutes? Means we have to just find the temperature of your body after 40 minutes. So we will just see this example by Newton's cooling law. The temperature of the air, that is the temperature of your surrounding, is of 40 degrees Celsius. So we said that the temperature of your surrounding, that is the theta naught, is equal to 40 degrees Celsius. So according to Newton's cooling law, by Newton's cooling law, d theta upon dt is minus times k theta minus theta naught, where the value of your theta naught is 40 degrees. So we have to replace the value of your theta naught in this differentiable equation. So the equation becomes d theta upon dt is equal to minus times k in bracket theta minus 40. That is our differentiable equation. So we have to just find the temperature of your body at 40 minutes. For that, we have to reduce this differentiable equation into variable separable form. The variable separable form of this differentiable equation is d theta upon theta minus 40 is equal to minus k dt. This is our equation number first. We have to just apply first two conditions on your differentiable equation, which is expressed in your variable separable form. So we are just using the condition number first as t equal to 0, the theta equal to 80, and t equal to 20, the theta equal to 60. So we have the integration of such a differentiable equation with the limit as t tends t is equal to 0. At the same time, your theta is equal to 80 degree. So this is the differentiable equations solution after variable separable form. Is putting the limit of your t and theta, and we know that the integration of d theta upon theta is simply log theta. So we have to just taking minus k, which is a constant outside the integration, and taking the integration on your both the sides. The integration of your d theta upon theta minus 40 is log of theta minus 40, and this particular terms in which the upper and lower limit is there. Again, the integration of dt is t, and the limit of your integration goes from 0 to 20. So after replacing the value of your upper and lower limit, we got log 60 minus 40, log 80 minus 40 is equal to minus times 20 minus 0. Upper limit minus lower limit. So the subtraction of your 60 minus 40 is 20. Subtraction of your 80 minus 40 is again 40, and the 20 minus 0 becomes 20. So again, log a minus b is nothing but your log a upon b. We use this formula for the simplification. So we got log 20 upon 40 is equal to 20 minus 20. Again, we have to make the simplified form of this. We know that the 20 upon 40 becomes 1 upon 2, and this k is multiplied with minus 20, so it becomes minus 20 upon log 1 by 2. It is the value of your constant k. We require the value of your constant of constant to find the value of your temperature after 40 minutes. For that, we have to use the condition number first and the last condition. It means at T is equal to 0, the temperature is 80 degrees Celsius. After 40 minutes, what is the temperature of your body? So we assume the temperature of body is equal to suppose theta. The question mark in the sense we have to assume the body whose temperature is theta. So we have to find the value for theta here. So again, we have to use the variable separable form of that differentiable equation. And the differentiable equation is here d theta upon theta minus 40 minus k dt. Again, minus k is your constant of your integration. We have to keep outside your integration. So we got this integration. Again, taking the integration of this, we got log of theta minus 40. Upper limit is theta, lower limit is 80. On the right hand side, upper limit is 40 and the lower limit is 0. Replacing your upper and lower limit, we got log of theta minus 40 minus log of 40, 80 minus 40 minus 40 in bracket minus 0. Again, the subtraction is 40. Subtraction is 40. Again, the rule of your log a minus b is equal to log a upon b is equal to this. And we know that the value for k is equal to 1 upon 20 log of 1 by 2. Replacing the value for k in your equation number C, we can find the value for theta. So replacing the value for k in your equation number C, we get log of theta minus 40 upon 40 is equal to minus 40 in bracket minus 1 upon 20 log of 1 by 2. So minus 40 and 1 minus 1 upon 20 becomes 2. So the 2 is a multiplier to right hand side of your log of 1 upon 2. It becomes 1 upon 2 raised to 2 in by index rule. Again 1 upon 2 bracket square becomes 1 upon 4. And taking exponential on the both the sides, we get theta minus 40 upon 40 is equal to 1 by 4. And simplifying this, we get the value of your theta. Cross multiplication, the 4 is multiplied to your numerator on your left hand side, and 40 is multiplied to your right hand side numerator. So we got 4 theta minus 160 is equal to 40. Again, the 160 is shifted to right hand side, it becomes 200. The 4 theta is equal to 200. And then theta is equal to 200 upon 4 becomes 50 degrees Celsius. It means the temperature of your body after 40 minutes is 50 degrees Celsius. So in this way, we can find the temperature of the body at any time. And if the temperature of the body is defined, we can find the time that required to cool the body up to that temperature. Thank you. We will just see the next topic.